Hello everyone, welcome back to Quantum Science Hub. In this video, we will discuss Chapter 4 of IGCSE Chemistry, Electrochemistry, based on the latest IGCSE syllabus. So, let's get started. First of all, we will talk about electrolysis. What is electrolysis? Electrolysis is the process of breaking down or decomposition of ionic compounds into molten or aqueous solution by using electricity. This is the picture of electrolysis. So in this picture, you can find two electrodes, which is anode and cathode, and also electrolyte. Maybe some of you will ask, what is electrode? Electrode is a rod of metal or graphite through which an electric current flows into or out of an electrolyte. So this is the rod of the metal. When it is connected to positive, it is called anode. And when it is connected to negative charge from the power supply, we call this is cathode. Okay, if you still remember the electronic circuit symbol, the longer line here is positive and the shorter line here is negative. And what is electrolyte? Electrolyte is ionic compounds in molten or dissolved solution that conducts the electricity. So this is the electrolyte or the liquid in here. It can be molten or dissolved solution. I find out there are so many students that say to me this chapter is very hard. When they learn this chapter, they feel panic. But I always told them, please don't be panicked because I will use the word panic to help you remember this chapter. What is panic? Positive anode, negative is cathode. So again, when it is connected to positive, it is called anode or positive electrode. And when it is connected to negative, this is what we call cathode or negative electrode. And remember, electric current is conducted by two different ways in electrolysis. From the power supply to electrode, this is the movement of electrons. So the movement of electrons from the power supply is from positive to negatives, or the movement of the electricity. And in the electrolyte, it is the movement of ions. Since this is positive electrode, so who will attract it to positive? All negative ions, right? So that is why negative ions is called anion. Since this is negative electrode, so who will attract it to negative? Positive ion. And this is what we call cation. Okay? Now let's see the experiment to show the ion movement in electrolysis. So this is the picture of electrolysis. This is the electrode and this is the longer line, right? So this is the positive electrode and this is a shorter line. So this is the negative electrode. And this is the cable which is connected to a bulb. Why it is connected to the bulb? Because it is to prove if there is a current. When there is a current in here, so the bulb will on, right? It will lights up. But when there is no current, so the bulb will off. So first of all, I will use solid and ACl. Again, in the electrolyte here should be ionic compound, right? And an ACl is ionic compound. If you still remember how the ion movement of a solid, the ions are held strongly in crystallized lattices. So in this case, no current when the salt or the NaCl is in solid state. Why? Because the ions are held strongly in crystallized lattices. So at the end, we can see the light bulb does not light up. Okay? After that, I will heat this NaCl. So what will happen to this NaCl? It will melt, right? So after the solid NaCl melts, it will turn into molten NaCl. So in this case, since it is a molten, the ions are free to move about. So the current flowing when the NaCl salt becomes molten. As the result, the light bulbs can light up. So this is a proof if we are using molten NaCl or aqueous NaCl, the ions in electrolytes can move. So the light bulb lights up. Okay? From the experiment, we know that electrolyte can conduct electricity only when it is molten or dissolved in water. So that means it should be in a liquid state, right? When the electrolyte is in solid state, the ions are held in crystallized lattices. They are not free to move about, so no current is conducted. But when the electrolyte is in liquid, the ions can move about because the crystallized lattice structure has broken down. Therefore, the movement of ions is able to conduct electricity. So this experiment shows that ions in ionic compounds are held in a lattice during solid state, but are free to move about in molten or in solution. And remember, electricity can only be conducted when ions move about freely. So that means it should be in liquid state, which is molten or dissolved in solution or water. Okay, now let's take a look at this electrolysis. In this electrolysis, what will happen at the anode? Remember, at the anode is positive electrode, right? So who will attract it to positive electrode? Something negative, which is Y negative in this case. So Y negative will lose electrons, and this is the ionic half equation. The ionic half equation is always from ions want to become atoms, right? So the electron we put at the right side. And this is what we call oxidation. Next, what will happen at the cathode? At the cathode, X positive will gain electron because this is a negative electrode or cathode. So who will attract it to negative electrode? Something positive, right? Or positive ion. So X positive gains electron, and this is the ionic half equation. In electrolysis, it's always from ions want to become atom. So we put the electron at the left side, and this is what we call reduction. So what you need to remember, oxidation happen at anode and reduction happen at cathode. For right now, we don't discuss what is oxidation and what is reduction because we will discuss this topic in the next chapter. But for right now, what you need to remember, only oxidation happen at anode and reduction happen at cathode. Okay? Please remember that. In a molten binary compound, there are only one type of positive ion and one type of negative ion. So during the electrolysis, the positive ions move to the cathode and gain electrons, while negative ions move to the anode and lose electrons. Okay, please take a look at this example here. So this is all the example of binary compound. Binary compounds, it means it only contains of two ions, right? One positive and one negative. For example, an ACl, so I have an A positive and Cl negative. So an A positive will accumulate at the cathode, while Cl negative will move to anode, right? What about PbF2? So we have Pb2 positive and F negative. So Pb2 positive will go to cathode and F negative will go to anode. What about Al2O3? What is the ion here? Al3 positive and O2 negative, right? So Al3 positive will go to cathode and O2 negative will go to anode. That's it. Now let's talk about electrolysis of molten compounds using inert electrodes. Okay, what is inert? Inert means unreactive. Inert electrode is a metal that does not take part or interfere in any chemical reaction, but it is still used to conduct electricity by transferring electrons with the solution rather than exchanging ions with the solution. Therefore, it serves as an electron. Platinum is used as an inert electrode and carbon or graphite is used widely because it is cheap. Okay? Now let's see the electrolysis of molten sodium chloride. So the ions of sodium chloride is an A positive and Cl negative, right? So an A positive will go to cathode or the negative electrode in here. And Cl negative will go to anode or positive electrode, which is in here. So Cl negative will go to here and Na positive will go to here. So as we know, sodium is a metal, right? So the sodium metal deposited. So it means it will get thicker, thicker, and thicker over time. While chlorine is the gas. So the chlorine gas discharged in here. So during the electrolysis, sodium ions move to the cathode to pick up electrons and form sodium metallic element, while chloride ions move to anode to lose electrons and form chlorine gas. From this experiment, I can continue to make the table like this. So what will happen at the anode and what will happen at the cathode? Again, at the anode, chlorine ions are discharged, right? So what will you see in here? If you're talking about observation, you cannot write I see chlorine gas, okay? Because we cannot see oxygen gas or hydrogen gas or any gas because the gas name is not written in the air, right? So the observation here, you can just write the color of the gas. So you can say a pale green or the yellow green gas is produced. While at the cathode, sodium ions are discharged. They gain electrons to form sodium metal. So what is the observation? A silvery metal is produced, right? Because it is in group 1 and sodium is silver color. And this is the ionic half equation in anode and cathode. So what will happen at the anode? This, right? So from ions want to become atom. And Cl is a diatomic gas, so that's why you should put 2 in here. But just because you put 2, now the Cl here is Cl2, right? But in here, the Cl still Cl1, so that's why you will put the coefficient in front here is 2. And that's why you put 2 electrons in here. And at the cathode, actually it's just an A positive plus electron will give an A. But remember, to balance the overall chemical equation, we need the same number of electrons. So if you have 2 electrons at the anode, you should write 2 electrons at the cathode. So you times all with 2. So 2 Na positive plus 2 electron will give you 2 Na. So this is the overall chemical equation. Now let's see the word example 1. Molten lead-2 bromide is electrolyzed as shown below. Okay, so the first question, name a suitable material to be the electrodes. It can be graphite or carbon or platinum, right? You can choose carbon or graphite or even platinum. Anything works. Next, write the ions that are present in molten PbBr2. So what is the ions? Pb2 positive and Br negative, right? Next, write the ionic half equation taking place at the anode and at the cathode. Okay, what is anode? Anode is positive electrode. So what is attracted to positive? Something negative, right? So it should be Br negative from ions want to become atom. Since bromine is group 7, so it's a diatomic molecule, so you have to put 2 in here, and to balance the equation, you also need to put 2 and 2 electron in here. And cathode is the negative electrode, so what will attract it to negative? Something positive, right? So it should be Pb2 positive. So Pb2 positive plus 2 electron will become Pb. Next, write the overall equation for the electrolysis of molten PbBr2. So we can remove the electron. So at the end, you will have Br negative with Pb2 positive, and you will have Br2 and Pb, right? So the answer here is PbBr2 will produce Br2 gas plus Pb solid. Okay, that's it. Now let's see the word example 2. Complete the table for the electrolysis of the following molten compounds. So this is the molten binary compounds. Okay, let's start with calcium fluoride. What is the ion for calcium? Calcium is Ca2 positive, but fluoride is F negative, right? So the formula here is, I will take yours, you will take mine, so Ca1F2, right? So the formula here is CaF2. And what is the ionic half equation at the anode? Remember, anode, it means it is positive electrode, while cathode is negative electrode. So what is at the anode? We will have from ions want to become atom, right? And fluorine is a diatomic molecule. So you put 2 in here, but just because you put 2, now the F here also get affected because the F at the left side is still 1. So you put 2. Now the charge here is 2 negative. So to make it balance, you need to put 2 electron at the right side, okay? While at the cathode is from Ca positive want to become atom. And it is monoatomic, right? It is not diatomic molecules. So how to balance the ionic half equation? Just put 2 electrons in here, okay? And what about the overall chemical equation? Now make sure they have the same number of electrons, which is 2 and 2. So altogether will be CaF2 will become Ca plus F2. Okay? It's gonna be pretty easy because they have the same number of electrons. Next, potassium bromide. Potassium, the ion of potassium is K positive and bromide is Br negative. So I will take yours, you will take mine. So the chemical formula is KBr. Okay, again, it is the same with fluoride since they are in the same group. So it should be from ions want to become atom. And bromine is also diatomic molecules, right? So you need to put 2 electrons in here and 2 coefficient in front of Br negative. Next, what about the cathode? It should be K positive plus electron will become potassium atom, right? Now, this is the problem. You can see here at the anode we have 2 electrons, but at the cathode we have 1 electron. Okay, so how to solve this? So at the anode, just rewrite it. 2Br negative will become Br2 plus 2 electron, while the ionic half equation for the cathode, we times all with 2. So become 2K positive plus 2 electron become 2K, right? Now you can cross the electron. Then what is left? 2KBr. So the overall chemical equation here is 2KBr will become 2K plus Br2. Next, what about aluminum nitride? What is the ion of aluminum? Al3 positive, right? Al3 positive and nitride, it is nitrogen. So, N3 negative. So I will take yours, you will take mine. So they have the same number of the chart. So the formula is AlN, okay? Not Al3 N3, but AlN. So the formula here is AlN. What is the ionic half equation at the anode? From ions want to become atom, and nitrogen is also diatomic gas. You need to put 2 in here, and you also need to put 2 in here. Now the charge here at the left side is 6 negative, so you need to put 6 electron in here. What about at the cathode? So from ions, Al3 positive want to become atom, aluminum, okay? And this is 3 positive, so you need to put 3 negative in here. Now, how to make the overall chemical equation? Now you can see at the cathode we have 3 electrons, while at the anode we have 6 electrons, right? So we need to times all the ionic half equation at the cathode by 2, okay? So we have 2 and 3 negative become N2 plus 6 electron, and we times all with 2, so we have 2 Al3 positive plus 6 electron will become 2Al. Now you have the same number of electrons, so you can cross them. So at the end, you will have 2Aln will become 2Al plus N2, right? So this is how you solve the question, okay? Now let's talk about electrolysis of solution by using inert electrodes. When a substance dissolves in water, it forms a solution. A solution is a mixture of 2 types of electrolytes. The first type is the ions from the dissolved substance, and the second type is the ions from the water. Water molecules dissociate into H positive and OH negative. So that means if it contains of water, it always contains of H positive and OH negative. And the ionic compound X positive, Y negative dissociates into X positive and Y negative. Now let's take a look at this table. For example, I have dilute HCl solution. So the ions from the dissolved substance contain of HCl, right? So H positive and Cl negative. While from the water, of course, it always contains of H positive and OH negative. Next, concentrated NaCl solution. So from NaCl, it contains of Na positive and Cl negative. And the same thing with the water. Next, aqueous copper sulfate solution. So from the dissolved substance, it contained Cu2 positive and SO4 2 negative. And from the water, again, it always contains of H positive and OH negative. When there are two or more cations and anions in the solution, selectively discharge of ions is applied at both electrodes. The selectively discharge of ion is mainly affected by, so the first one is for positive ions. It is based on the position in the metal reactivity series. The lower the position in the metal reactivity series, the more preference for the positive ion to be selectively discharged. For example, I have an ACl aqueous. So it contains of Na positive and Cl negative. While from the water itself, it always contains of H positive and OH negative. So who will attract it to anode? Anode is positive electrode, right? So you have two choices in here, Cl negative or OH negative. So who will attract it to anode? So this is the problem. Okay, so there's some kind of the rule for selectively discharge of the ions that applied at both electrodes. And for positive ions, it based on the position in the metal reactivity series. And we are choosing the lower position in the metal reactivity series. Now, what is metal reactivity series? So this is the metal reactivity series. It starts from potassium, which is the most reactive metal, and gold as the least reactive metals or very unreactive. And this metal reactivity series should be in order. So that's why I already helped you to put some kind of abbreviation to help you easily memorize and remember this metal reactivity series. Please stop calling me a cute zombie in London house because somebody got away. Please, potassium, and this is a symbol of the element. Stop, sodium. Calling, calcium. Me, magnesium. A, aluminum. Cute, carbon. Zombie, zinc. In, iron. London, lead. House, hydrogen. Cast, copper. Somebody, silver. Got away, gold. Okay? Now, I put some kind of bracket in here, which is carbon and hydrogen because they are not a metal. But why should I put in here? Because we will still use this metal reactivity series in the topic of metal extraction. So that's why it's better for you to memorize like this, even though carbon and hydrogen is not a metal. But again, you just need to memorize these metal reactivity series, but you get two benefits which you can use in the topic of electrolysis and extraction of metal. Okay? Next, for negative ions, it is affected by one of these factors. In dilute solution, OH negative always discharge at anode. So that means in dilute, we always take OH negative. What is dilute means? It contains a lot of water. While in concentrated solution, it means it contains less water. So we take the more concentrated substances as the negative ions that will be selectively discharged. For example, in a concentrated sodium chloride solution, the negative ions present are Cl negative and OH negative, right? So Cl negative is from the substance and OH negative is from the water. But it is concentrated, so that means it contains a lot of Cl negative ions. So that's why Cl negative will be selectively discharged because it has a higher concentration than OH negative. But when you have dilute sodium chloride solution, it's not only sodium chloride, you can choose dilute whatever the chemical compound, it always should be OH negative that will be selected because it contains a lot of water and water contains OH negative ions. Now let's see the electrolysis of concentrated sodium chloride solution. Okay, sodium chloride, it is NaCl, right? From the water, H2O because it contains of water. So from NaCl, we have Na positive and Cl negative. From the water, it always H positive and OH negative. So these are the ions that present in concentrated sodium chloride. Next, please take a look at this table. So the electrolyte here is concentrated NaCl solution. So who will attract it to anode? Anode is positive electrode. So all negative ions will attract it to positive, right? Which is Cl negative and OH negative. And cathode is negative electrode. So who will attract it to negative? Something positive, which is Na positive or H positive. So this one. Now please take a look at the rule. Which ion that you choose at the anode? For the negative ions, we always choose the concentrated solution. So concentrated NaCl solution, that means it contained a lot of Cl negative ions. So that's why we choose Cl negative. So we choose Cl negative from ions want to become atoms, and Cl is diatomic molecule. So we put 2 in here, and that's why we also put 2. Now the charge at the left is 2 negative, and I will put 2 electrons to make it balanced, right? So I will choose Cl negative for the negative ion. Now, what about for the positive ions? Should I choose Na positive or H positive? Remember, based on the rule that we already discussed before, for the positive ions is based on the metal reactivity series, and we take the lower position in the metal reactivity series. If you check it one more time, sodium is above hydrogen. So we choose the lower position in the metal reactivity series. So that's why we are choosing H positive. So it always from the ions want to become atom. And hydrogen is diatomic gas. So we put 2, but the hydrogen here is still 1. So that's why I will put 2. Now the charge at the left side is 2 positive, and that's why I will put 2 electron in here to make it balanced, right? So 2 positive plus 2 negative is 0, and the charge at the right side is also 0. Now, this is the observation. If there is a question, what you can observe at the anode and cathode, you can write bubbles of green gas. Please do not write bubbles of chlorine gas, because observation is something that you can see with your eyes. For example, you see colorless gas, you see yellow gas, it increases in mass, it becomes smaller, it becomes bigger, something like that. So chlorine gas is the green gas. You can say bubbles of green gas. Next, at the cathode, you can say bubbles of colorless gas, because hydrogen is colorless gas. Now, since Cl negative and H positive is taken, so who will be left at the electrolyte at the end? NaOH will be left, right? And what is NaOH? Na positive and OH negative. So this is NaOH, sodium hydroxide, right? So the solution gradually becomes alkaline. Why? Because NaOH is a base or alkaline, because sodium hydroxide is left in the solution. Got it? That's it. Now let's see the electrolysis of dilute sodium chloride solution. So the electrolyte we use in here is dilute NaCl solution. From NaCl, we have Na positive and Cl negative. And from water is always H positive and OH negative. So who will attract it to anode or positive electrode? All the negative ion. And who will attract it to cathode? All positive ion, right? So if you still remember the rule, if it's dilute, so we choose OH negative, right? And this is the ionic equation involving electrons. So 4 OH negative will become O2 plus 2 H2O plus 4 electron. And this is the balance equation. So what is the observation at the anode? You will have oxygen gas in here, right? So it is the bubbles of colorless gas, because oxygen is colorless gas. And what about at the cathode or negative electrode? The positive ions will attract it. So which one will you choose? Sodium or hydrogen? So if you check in the metal reactivity series, hydrogen is lower than sodium, right? So we choose hydrogen in this case. So 2 H positive plus 2 electron will become H2. So the product here is hydrogen gas. Then the observation here is the bubbles of colorless gas. So OH negative is taken and H positive is also taken. Then what will be left in the electrolyte? NaCl, right? So That's why you can see in here the solution becomes concentrated sodium chloride solution because water is used up at both electrodes. So OH negative and H positive, that means it is just the electrolysis of water. So you remove the water, at the end, it will turn into concentrated and ACl solution over time, right? Okay, now let's see the electrolysis of aqueous copper 2 sulfate solution. Please look at this table. So the electrolyte we are using here is aqueous copper 2 sulfate solution by using graphite or carbon electrodes, right? From the substance, we have copper 2 sulfate. So we have Cu2 positive and SO4 2 negative. And from the water, it always H positive and OH negative. So who will attract it to anode or positive electrode? OH negative, right? Because for negative ions, for aqueous, it is just the same with dilute solution. We never electrolyze sulfate. So we are taking OH negative. So the equation here is 4OH negative will produce O2 plus 2H2O plus 4 electron. Since we have oxygen in here, so what is the observation? The bubbles of colorless gas. Now at the cathode, we have Cu2 positive or H positive. So which one will be chosen? We will choose copper because if you check in the metal reactivity series one more time, copper is below hydrogen. Again, we take the lower position of metals for positive ion in the metal reactivity series, right? So Cu2 positive plus 2 electron will produce copper, and the color of copper is red. So you can say the observation here is red metal deposits. So that means the metals will accumulate at the cathode, and that's why the cathode will become bigger, it will increase in mass. Now please take a look in here. Since we are taking OH negative and Cu2 positive, so who will be left at the electrolyte at the end? It is SO4 2 negative and H positive. What is this? This is H2SO4, which is sulfuric acid, right? So you can say the solution gradually becomes acid because sulfuric acid is left in the solution. Now what can you observe in the solution? As we know, the original color of copper 2 sulfate solution is blue. At the end of the reaction, sulfuric acid is left in the solution, which is colorless. Remember, most acids are colorless. So you can say the blue solution turns colorless. Okay, that's it. Now let's talk about electrolysis of dilute sulfuric acid solution. Again, if we are using dilute something, so it always OH negative will be chosen at the anode, right? So 4OH negative will produce O2 plus 2H2O plus 4 electron. And the observation here is the bubbles of colorless gas because the product here is oxygen. And at the cathode, you don't have any other choices instead of choosing H positive, right? So 2H positive plus 2 electron will produce H2. So this is hydrogen gas. So what can you observe? Bubbles of colorless gas as well. Since OH negative is taken at the anode and H positive is taken at the cathode, then what is left in the electrolyte? H positive and SO4 2 negative. So what is this? H2SO4. But you remove the water, so it will become concentrated because now it contains less water. This is just electrolysis of water. So you can say the solution becomes concentrated sulfuric acid solution because water is used up at both electrodes. Okay? Now let's talk about the purification of metals. So this is the process of removing the impurities of metals by using electrolysis. So please remember, a pure metal can be separated from its impurities by electrolysis. The metal sample containing impurities is used as an anode. So in this picture, I want to remove the impurities in copper. So this is the impure sample containing copper. While at the cathode, a thin sheet of the pure metal is placed because I want to remove the impurities from the copper. So at the cathode, I should use pure copper in here. and both electrodes are dipped into salt solution of the metal. So I want to remove the impurities from copper, so that's why the electrolyte also contain of copper something something. So in this case, I'm using copper 2 sulfate solution. So the impurities will sink to the bottom of this beaker. So what will happen at the cathode? Impure sample containing copper is placed and the copper dissolves to form copper ions. Okay, so it will form copper ions. So from atom will become ions. And this is the ionic half equation. While at the cathode, a thin sheet of pure copper is placed and the copper ions are discharged and coated on the pure copper sheet. And this is the ionic half equation. So from ions want to become atom. Okay? Now let's talk about electroplating. What is electroplating? So electroplating is a method to coat an object with a metal. What is the uses of electroplating? Coating an object to improve their appearance, for example, to make it shiny, and to prevent it from corrosion. So this is the picture of electroplating. So in this picture, I want to electroplate or I want to coat this spoon by using this metal. So the first thing that you have to remember, the thing that you want to cover, in this case, this is the spoon, should be put at the cathode. And the metal should connect it to the anode, right? And the solution should contain something of the ions from this metal. So at the anode, a pure metal used for electroplating is placed. It dissolves and forms deposit on the object at the cathode. At the cathode, the object to be plated is placed. It is then dipped in a solution containing ions of the plating metal. Now let's see the example of electroplating of spoon by using silver metal. So first of all, we connect a silver rod to the positive end of the battery by using copper wires. Next, clean the surface of the spoon with sandpaper to remove dirt, grease, and oxide layers so the silver can stick properly and form a smooth coating. And after that, we put the spoon in a beaker containing silver nitrate solution, because I want to cover the spoon by using silver metal, right? So the solution also contains of silver something something. So in this case, we are using silver nitrate. Next, we connect the spoon to the negative end of the battery. And this is the picture of electroplating of spoon by using silver. Again, the spoon is connected at the cathode and the silver metal is connected to the anode. And since you want to cover this spoon by using silver metal, so the solution here, we are also using silver something something. So we can use silver nitrate. So all the ions from this metal will move to the spoon. So the spoon will become thicker and will be covered by silver metal. So what is the equation at the anode? It is from atom want to become ions, right? So Ag will become Ag positive plus electron. And what will happen at the cathode? From ions, it will stick to this. So it will become an element. So the equation is Ag positive plus electron will become Ag. Okay? Now let's discuss about hydrogen-oxygen fuel cells. Hydrogen-oxygen fuel cell uses hydrogen and oxygen to produce electricity with water as the only chemical product. The hydrogen-oxygen fuel cell produces electricity by combining both elements, releasing energy and water. So the overall equation for the reaction for hydrogen-oxygen fuel cell is hydrogen plus oxygen will become water, right? H2 plus O2 will become H2O. And as the result, it will release a huge amount of energy. And we can use that as the source of energy. Now let's talk about the advantages and disadvantages between hydrogen-oxygen fuel cell with gasoline or petrol engine. So the first advantages by using hydrogen-oxygen fuel cell is it produces only water, so it causes less air pollution. So that means it is a clean energy. Next, more energy efficient because more chemical energy is converted into electrical energy. So that means it produces more energy. And it is a renewable resources because we have unlimited of hydrogen gas in this world. But there are also some disadvantages in here. First, hydrogen is difficult and expensive to store because it is highly flammable and can explode under pressure. And there is a risk of fire or explosion if the fuel tank is damaged. So this is very crucial and very dangerous because if something bad happens, it will explode and the explosion is very huge. And there is a very limited number of hydrogen filling stations available. And that's the reason why even up to this day, we still use fossil fuel or gasoline or EV cars. EV car means it is electric car for transportation. And what is the advantages by using gasoline or petrol engine? First, petrol is easier to store and transport, and petrol engines are cheaper and more common in cities. And there are more petrol filling stations than hydrogen filling stations, and yeah, that's correct. Now, what is the disadvantages by using gasoline or petrol engine? First, it produces carbon dioxide and other harmful gases. So it will still give a little bit air pollution. And less efficient because much energy is lost as heat. So that means it produces less energy compared to hydrogen oxygen fuel cell. And it is a non-renewable fossil fuel. And that means one day it will eventually run out. Okay? So that's all about this chapter, Electrochemistry. We will discuss some past paper questions related to this topic in the next video. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.